Mr. Potts asked you, how are we going to shift this one across? What do we do? It's going to be negative. Okay, my value is going to be negative what? Looking at my coordinate for my vertex. 7.15. Awesome. So we would have in here negative brackets x minus 7.15. And move it across. We're going to then square it. And then I can see that that's my orange one. It's not in the right place, so I now have to shift it up again. So how do I shift it up? Plus 12.64. So that's my one. Okay? So there, you should all have something like, I mean, obviously I've kept all of my pictures on here. You don't need to keep all your diagrams. The snipping tool is the best tool in the world. So just snip stuff, paste it into documents as you go. Show your steps and show them what you're going through. Do you want to carry on, Mr. Poots?
Okay, so it still doesn't fit, but what you can do is say, right, I've got the vertex lined up. That's great. That's step one done. Okay. What is not quite right on ours at the moment? The width. Now, this is, I guess, where we differentiate between those that are showing really good understanding of how to fit the function and those that sort of know what they're doing-ish, but not fully. What would I now look at to get the width correct? So what's that?
What do you mean the outside?
I say the coefficient outside the bracket. So how would we go about adjusting that? Because that would work, because I know you've been doing that, yeah?
Do you want a big number? Do you want a small number?
So that is one way to do it. You can then start going, I just need to a bit more. However, for those of you that may be thinking a slightly different way, what actually have we not solved for yet? Which is the normal, the x. The roots, the x-axis intercepts, we haven't solved for those, and that's the normal thing for you guys. Even at IGCSE, you're asked to solve where f of x equals 0, right? You've got lots of ways to do that. So really, if we were going to go down that route, we ought to be starting with that function that we've already come up with, and then trying to adjust it in some way so that either when I factorise or I use the carry on with completed square form, if I try and use the formula, whatever, that I get the roots that I want without changing my vertex. So that's where your exploration would take you if you're properly exploring the function and solving it rather than trial and error. But either way has its merit. What you're actually looking at is, are you asking those questions of, well, what if I change this? Then it's the mathematics of it then, well, how are you answering that question? Are you doing it through trial and error, or are you doing it through actual mathematical numbers, manipulation, that kind of thing? So that would affect your maths criteria. But in terms of engagement, reflection, communication, notation, all of that, you can do either way and just say, well, this doesn't work. What do I need to do to change it? So if you say, I'm going to find the roots, or you say, I'm going to change the coefficient, fine, you saying it. Reflect on what happened, how close are you? Right? Now, has anyone actually got quite close to it? I know neither. So. Anyone got there, changed it a bit yet? Some people, yeah? So you've kind of got close. I can see Courtney's as well. What do you think about it as a model for that shape? It's not very close. Why? So certain points, now you have plotted points, and some of those points work better than others, and you've managed to fit certain ones, but some of them will be off, and this is again reflecting. Then you think, well, if it doesn't work, is there a different type of function that I could be using? Which there is for this one. But starting point is a parabola, that's what we think. We go through and model the function. We get to a point and say it's not quite right. Why is it not quite right? What do I try next? And that's where your exploration goes, step by step. It's a cyclic thing of identify the problem, try and solve it, give it a go, reflect on what's wrong, identify the next problem, and keep going until you're happy. Okay? So have a go at seeing how close you can make yours now, and really prove me wrong.
Okay, you all good? Now, just one thing while I'm recording this, just to remember, when you are writing up your exploration, I did mention it to my class the other day, it's really important that you do define your variables and you define your parameters. Do we all understand what parameters and variables are? Yes, no, hello? Anyone out there? Okay, the variables you should be fine with. What variables have we been, what are the variables we're looking at here? X and Y. What does X represent on, like, what units does it have? What's it representing? Yeah, meters, it's the width between the base of the thing. And here, this is meters, this is my height of the parabola, okay? So you need to make sure that you're mentioning that. The parameters are then basically the coefficients. So if we were just talking about a basic x squared, you would say that it's y equals maybe a x squared, okay? So this would be one of your parameters. So you would just say, what effects does that have? That affects the width of it. Okay, so just talk about those kinds of things, and so that within your project, that makes sure that you are showing the person marking it that you are aware of why these numbers are changing and what effects it has on it. Okay, so you should be defining your parameters and your variables in your project. It does say that on the mark scheme thing.
And actually, as Ms. Harrison told you yesterday and earlier, if you talk about the realistic size of the objects, then you're kind of halfway there already. Because you're saying, well, I need these to be this wide because that's the width of the shape. You know, you can find those values online, no problem with something like this. So that will help you to find those numbers and explain it as well.
Okay. Right, so I'm going to stop this, and that's the end.
Actually,